Now, let us discuss the problem based on the rate constant, that is temperature dependence of rate constant. So the rate constant given here, there are two rate constants given, that is 0.02 per second, 0.07 per second. Just by looking at the unit, you may be able to that is confirm that this is the the rate constant of first order reaction. So you can put K1, K2, and then these are the two different temperature. So we can mention this as T1 and T2. Calculate the EA, so energy of activation, and that is a frequency factor. Arrhenius a frequency factor. So these two are to be found out. So we need to apply two equations. What are given here? Let me write down the given first. Given T1 500 Kelvin, T2 700 Kelvin, K1 0.02 per second, K2 0.07 per second. Now what is asked to find out? EA, energy of activation, then Arrhenius frequency factor or Arrhenius factor or frequency factor. Now what are the equations to be applied? We have two important equations based on temperature dependence of rate constant. So what is the concept here? The temperature dependence of. So what is the concept? Temperature dependence of rate constant. So we have two equations. The logarithmic representation is, that is log K2 by K1 is equal to EA divided by 2.303 or into T2 minus T1 divided by T1 T2. So this is the important equation where we need to apply the parameters given. And the second equation is we need to find out Arrhenius factor. So for which we have to use K is equal to A e power minus EA by RT. So this is another set of equation. We have to use this as a tool to solve this problem. Let us substitute. Let us make use of the first equation, first formula to find out what, that is the K. Now not K, that is energy of activation, EA. So let us rewrite this log K2 by K1 log K2. This is the solution. So K2 by K1 is equal to, what is that? EA divided by 2.303 into R into T2 minus T1 divided by T1 T2. We know the value of R, universal gas constant, that is 8.314 in joule per Kelvin. Okay, joule per Kelvin per mole. right? Now let us proceed. So the log of 0.07 divided by, what is that? 0.02 is equal to, what is EA? We need to find out EA, and then 2.303 into or 8.314, open the bracket. Now or T2 minus T1, that is T2 is 700 minus T1 500, whole divided by 700 into 500. Okay, now let us work out, that is we had to find out log 0.07, that is equal to, that is 2 bar, because log 0.07 means, when you represent this in scientific notation, 7.0 into 10 power minus 2, that minus 2 should be written as 2 bar, and we had to find out the logarithm for 7.0. So let us go to our website where we can find out the 7.0, 8451. Okay, so it's here 7.00, that is 8451. Okay, so 0.8451. Similarly, a log of 0.02, it is a 2 bar, and for 2 it is a 3010. 3010. You have to refer the logarithm table. Now let us subtract. So we have to apply the, what do you call this, quotient rule. So when you find the quotient or division, you have to subtract the logarithmic value. So 1 minus 0, 1. What is this? 5 minus 1, 4. 4. And then here 8 minus 3, 5. And this is minus of minus plus. So 2 bar plus 2, 0. So this value is 0.544. So 0.5441 is equal to EA divided by, and you have to find out the logarithmic value of 2.3. You first do this. Let us work out finally. 3.3 into 8.314, and then what about this? 200 divided by 35 into, we can put 10 power 4. Okay, now we can bring everything to this side, and we have to find out EA. Therefore EA is equal to, what is that, 0.5441 into 2.303 into 8.314 into 35 into 10 power 4. Okay, and then whole divided by 200, right? Whole divided by 200. Let us work out this by logarithm. So we have to find out EA. So this is the numerator part, and this is the denominator part. So first we will work out the numerator part. Since all are in multiplication, we have to find out the logarithmic value one by one and add everything. Okay, so we'll proceed with the numerator first. So what is the logarithmic value of a 0.5441? You should be, if it is 0.5 means a 5.441, so you can put 1 bar. Okay, put the 544 value. Similarly here 2.303 means 0 point, you have to check the value 23 in 0 and 3 mean difference, and 8.34 means that is also 0 point. And what about this? This is 35. 35 means that is 1 point. Then we have to find out the logarithmic value. Then 10 power 4 means, which is nothing but 4. Okay, now we'll find out one by one. 5, 4, 41. So what is the logarithm of 5441? So we will find out 5441. Okay, just check it here. 5441. So 54 and 41. That is this one. In 4 and mean digit 1. Okay, mean difference 1. So 5441. 54 4 0.7356 and 1 1. So 5357. Am I right? 7357. 7357. You have to be very careful. 7357. Okay. So 7357. And then 2.303. So 2303. That is the logarithm we had find out 23. So 2.3 not 3. So 2.3 not 3617 and then 3. 3 means mean difference 6. So 23. So 3623. Is it not? So 3623. So we need to write 3623. And then 8.314. So 8.314. Go to 8.314, 8.314, 8.31, 9196 and 4 is 2. So 9198. Is it not? So 9198. 9198. 8. And then for 35. Is it not? So we have to find out for logarithm for 35. 35 means 3.5 in 0. So 3.5 0. 5441. 5441. So you can write that is 5441. Okay. For 10 power 4 it is a 4. You can simply put 0 0 0 because logarithm of 10 power 4 is 4. Okay. Now add everything. 7 plus 3, 10, 18, 19. Balance 1, 5, 14, 16, 5, 21. Balance 2, 6, 7, 13, 3, 16. Balance 1, 6, 15, 18, 25. Balance 2, 6, 7, 7 minus 1 again 6. Okay, so this is the numerator value and you have the denominator here, right? So let us include the denominator. So the denominator is 200. So log 200. Log 200 means that is if it is a 200. So you have to take the single digit. So 2.00 into 10 power 2. That is 2. For 203010. So you can write 2.3010. Now subtract, right? Now 9, 0, 6, 5 minus 3, 2, 6 minus 2, 4. Okay. Now for which we have to find out the anti-logarithm. So we'll go ahead with the anti-logarithm for 0.2609. So find out the anti-logarithm. What is the value? 2609. 0.2609. So you have to be careful. You have to find out the anti-log. Okay. So this is anti-log table and 2609. Is it not? 2609. So 26 is here. 26 in 0 and then go to the mean difference 9 4. So 260 means 4 you have to add. So 1.8200 0 actually. This is 0, 0. So 1.8204. Is it not? So 1.8204. 1.8204. So 1.8204 into 10 power, you have to put this value, the power in power 4. So this is the way you have to write down. Okay. So EA value is, therefore, EA, energy of activation, is equal to 1.8204 into 10 power 4. Energy of activation is in joule. Now, this is not over. We had to complete the problem. They have asked, this is the first answer. They have asked the Arrhenius factor. So where from we can find out? We have got the equation K is equal to A e power minus EA divided by RT. So we